Hey everyone, welcome back to another video from my channel. In our last video, we discussed about the dynamics of a particle moving in a straight line where we learned about force diagrams, Newton's three laws of motion, forces as vectors, connected particles, and finally pulley systems. Today, we will be expanding our knowledge and theories in forces by learning about resolving them in particular components if they are associated with angles. So first, let's dive into resolving forces. If a force is applied at an angle to the direction of motion, you can resolve it to find the component of the force that acts in the direction of motion. The book shown below is being dragged along the table by means of a force of magnitude F. The book is moving horizontally and the angle between the force and the direction of motion is theta. The effect of the force in the direction of motion is the length of AB. This is called the component of the force in the direction of motion. Using the rule for a right angle triangle, cos theta is equals to adjacent by hypotenuse, which I discussed in previous videos, you can see that the magnitude of the force in the direction of AB is F into cos theta. Finding this value is called resolving the force in the direction of motion. The component of a force of magnitude F in a certain direction is F cos theta, where theta is the size of the angle between the force and the direction. If F acts in the direction D, then the component of F in that direction is F cos 0, which is F multiplied with 1, which is also F. And if F acts at a right angle to D, then the component of F in that direction is F cos 90, which is F multiplied with 0 or 0, because as you can see, there is no horizontal effect. And if F acts in the opposite direction to D, then the component of F in that direction is F cos 180, which is also minus F. If you remember from the previous videos, we discussed about trigonometry, and in our right angle triangle where we have opposite here, adjacent and hypotenuse, then sine theta will be equals to opposite by hypotenuse and cos theta will be equals to adjacent by hypotenuse. So rearranging for A and O, we can say that O is equals to H sine theta or the opposite, and we can say for the adjacent A is equals to H cos theta. So if we have a force F in this direction with an angle of theta to the horizontal as given, then the horizontal component of F will be known as Fx and the vertical component of force will be known as Fy. And similarly, an easier way to remember the components is to recognize that the component exactly opposite to the angle is always the sine component and the other will be the cosine component of the force or vector, because using the same formula for sine theta here, opposite by hypotenuse, we can get sine theta is equals to Fy divided by F. So rearranging for Fy, we can get F sine theta, and similarly for Fx, it is F cos theta. So the component exactly opposite to the theta or the angle is sine theta, and the other component that is remaining is F cos theta. Now let's move on to some exercises from the book. From exercise 5a, we have number 7. A force of 20 newtons is applied to the box of mass m kg, causing the box to accelerate at 0.5 meter per second square along a smooth horizontal plane. Given that the force causing the acceleration is applied at 25 degrees to the plane, work out the value of m. For number 7, let's first draw the situation. If this is the plane, and if this is the box, this will be 20 newtons applied to the box at an angle of 25 degrees. And so there should be an acceleration to the right or towards the force, and resolving the other forces, we have normal reaction force here, and similarly this will be the weight or mg, and this will be the acceleration, which is 0.5 meter per second squared. Now we can resolve towards the right, because using Newton's second law, resolving towards the right, we can say that if we redraw the box as a particle, this will be 20 newtons with an angle of 25 to the horizontal. And so if you recall the force triangle associated with a right angle, if this is our given force and if this is theta with the horizontal, then this component will be F cos theta, and the component exactly opposite to the angle is F sin theta. So therefore we can say that this part will be 20 cos 25. So resolving to the right, you can say using Newton's second law, F is equals to mass into acceleration, or the resultant force is equals to mass into acceleration. So therefore resultant force is this, which is 20 cos 25 is equals to mass, which is m, and acceleration is 0.5. So therefore mass is equals to 20 cos 25 divided by 0.5, which is equals to 36.3 kgs. For number 9, a system of forces act on a particle as shown in a diagram. The resultant force on the particle is 2 root I plus 2j newtons. Find the magnitude of F1 and F2. So if we redraw the system, this will be the y-axis and this will be the x-axis. So if this is F1 and if this is 12 newtons, similarly this is F2 at an angle of 30 degrees. So therefore we can say that because F1 is directly a horizontal force, therefore F1 must be in the form of AI plus 0j. And if you remember the previous videos, we had a force being expressed as a vector, or AI plus bj, where I is the horizontal unit vector, where j is the perpendicular unit vector, just like this. So because F1 has no vertical components, so we can express that being AI plus 0 into j. So we can say that F1 is equals to F1I. For F2, if you notice, this is the angle of 30 degrees and this is F2. So therefore the vertical component here will be F2 sine 30 as discussed previously, and this part, or the horizontal component, should be F2 cos 30 as illustrated using the previous diagrams. And so we can say that F2 can be written as F2 cos 30 I with a minus because it is negative, minus F2 sine 30j, because minus F2 cos 30 is the horizontal component, and similarly F2 sine 30 is the vertical component. So resolving upwards or vertically, we can say that if this is the particle and this is 12, then the vertical component of F2, which is here, is F2 sine 30. So resolving vertically and drawing the particle, we can see that 12 is upwards and F2 sine 30 is downwards. Now because the resultant is given as 2 root 3 I plus 2j, which also looks something like this. 2 root 3I is somewhere here if this is I, and 2j should be here. if this one is j. So the resultant vector looks something like this. And so resolving vertically, we can see that there is a resultant force of 2j, so therefore this should be 2j as well. So resolving vertically using summation of F, or the resultant force is equals to mass into acceleration, or simply just using the resultant force theory. So we can say 12 minus F2 sine 30 is equals to the resultant force, which is also upwards, so it is 2. So 12 minus 2 is equals to F2 sine 30. So as we know, sine 30 is half, this is 10, so half into F2, so therefore F2 is 20 newtons. And similarly, for the horizontal resultant force, we can draw the diagram again. If this is F1 and this is the horizontal component of F2, which was F2 cos 30, which is here, and we know that the horizontal resultant force is 2 root 3 I, which is in this direction, also given here. So this is 2 root 3 I, and therefore resolving horizontally to the right, we can say that F1 minus F2 cos 30 should be equals to the resultant force in the horizontal direction, and so F1 is F1 minus F2, which is 20, multiplied with cos 30, which is root 3 by 2, equals to 2 root 3. So therefore rearranging F1 is equals to 20 multiplied with root 3 by 2 plus 2 root 3. 20 divided by 2 is 10, so we have 10 root 3 plus 2 root 3, and so the value of F1 is 12 root 3. So now let's talk about inclined planes. Force diagrams may be used to model situations involving objects on inclined planes. To solve problems involving inclined planes, it is usually easier to resolve forces parallel to and at right angles to the plane. For example, if we have a plane with an angle of theta to the horizontal, as illustrated here, we can use this angle, which is 90 minus theta, as we know that the sum of angles of a triangle is 180. So theta plus 90, which is this angle, plus alpha, assuming this is alpha, is equals to 180. So writing alpha in terms of theta, we get 180 minus 90 minus theta, which is also 90 minus theta. So therefore, because this angle is 90 minus theta, so accordingly, because this is also a parallel line, therefore this angle will also be 90 minus theta because of corresponding angles. And at this point, which is at the center of mass of the particle, we can say that if this is the inclined plane and if this is the perpendicular to the inclined plane, so therefore this should be 90, and so because this one was 90 minus theta, and if this whole thing is 90, therefore this must be theta. And if we zoom in to the right angle triangle, we can see that this should be the weight which acts vertically always, which is mg, as we have known in our previous video. Weight is equals to mg, so this should be mg cos theta, and this should be mg sin theta, which is parallel to the plane, and so the perpendicular component to the plane will be mg cos theta. as discussed previously. So if we have a full force diagram, this should be the reaction force and this should be the friction only if the surface is rough. So according to our logic before, the vertical component to the plane or the perpendicular component to the plane should be mg cos theta, and the horizontal component of weight parallel to the plane should be mg sin theta, and this should be mg. And if the particle accelerates downwards as shown here, therefore we can say that r is equals to mg cos theta, because if we discuss about the particle, this should be the normal reaction force which is perpendicular to the plane or the inclined plane, and this should be mg or weight. So if the angle is theta, therefore this component should be mg cos theta. So this is our first equation, r is equals to mg cos theta. And similarly, if we talk about the horizontal component or the component parallel to the inclined plane, which is this side, this should be mg sin theta. And as we know, friction will always act in the opposite direction of motion. So if this is friction, therefore mg sin theta, which is this component, minus friction is equals to mass into acceleration. So now let's move on to some exercise questions from exercise 5b. In number 1, a particle of mass 3 kg slides down a smooth plane that is inclined at 20 degrees to the horizontal. So for number A, we have to draw a force diagram to represent all the forces acting on the plane. So if this is the inclined plane, and if this is the horizontal plane, this should be 20 degrees, and this should be a particle of 3 kg. So this should be 3g, which is the weight, or mg. This should be the reaction force, or r. And because it is a smooth plane, therefore there should be no friction. And hence, the only horizontal force acting parallel to the inclined plane will be the gravitational acceleration, or in this case, the horizontal component of weight, which is mg sin theta. So in this case, it should be 3g sin 20. And here, which is perpendicular to the inclined plane, should be the vertical component of weight, which is 3g cos 20 degrees. And this is the full force diagram. For number B, we have to find out the normal reaction between the particle and the plane. And if we resolve perpendicular to the plane, which is r perpendicular to the plane like this, therefore, drawing the particle again, if this is r and if this is 3g cos 20, and there is no vertical acceleration to the plane, therefore we can say that r is equals to 3g cos 20, which is approximately 27.6 newtons using the calculator. For number C, we have to find out the acceleration of the particle. So as we know, this should be the horizontal resultant force parallel to the inclined plane. So therefore, using Newton's second law again, summation of F, or the resultant force, is equals to mass into acceleration. So resultant force is 3g sin 20 is equals to mass, which is 3 multiplied with acceleration. So therefore, acceleration is equals to g sin 20, which is approximately 3.35 meter per second squared. And this is our answer for number 1. So for number 8, a particle of mass m kg is pulled up a rough slope by a force of 26 newtons that acts at an angle of 45 degrees to the slope. The particle experiences a constant frictional force of 12 newtons. Given that tan alpha is equals to 1 by root 3 and that the acceleration of the particle is 1 meter per second square, So find out and show that m is equals to 1.08 kgs. So first, let's redraw the plane again, which would look something like this. If this is the particle and if this is alpha, we can say that because the mass is m, so this should be mg, which is the weight. Here is 12 newtons acting on the particle, and this is 26 acting at an angle of 45. Because there is an acceleration, we can say that the acceleration is parallel and upwards to the plane that is inclined. Therefore, this should be 1 meter per second squared, and this should be the reaction force. And because tan alpha is given as 1 by root 3, we know that tan theta is equals to opposite by adjacent. So if we construct a right angle triangle like this, if this is 90 degrees and if this is alpha, then the opposite should be 1 and the adjacent should be root 3. So therefore this should be 1 and this should be root 3. So using Pythagoras' theorem, we can find out the hypotenuse, which is h squared is equals to 1 squared plus root 3 squared. So h is equals to root over 1 plus 3, which is root over 4. As we know, 4 is equals to 2 square, so therefore root over 4 is 2. So therefore we can say that sine alpha is equals to 1 by 2 or half, and so cos alpha should be root 3 by 2, because we know that sine alpha is equals to opposite by hypotenuse and cos alpha is equals to adjacent by hypotenuse. So now let's draw the particle, and this should be mg as usual. This should be reaction force, which is R. This should be the frictional force, which is 12, and this should be 26 newtons with an angle of 45. So because acceleration is upwards parallel to the inclined plane with a value of 1 meter per second square, so therefore resolving upwards and parallel to the plane, we can say that if this is mg cos theta or cos alpha and this is mg sine alpha, so therefore we can say that the resultant force is 26 cos 45, because if you look at the force of 26, which is 26 here, and this is 45, this one should be the cos component, or 26 cos 45, and this should be the sine component, or 26 sine 45. So 26 cos 45 minus 12 minus mg sine alpha. So mg sine alpha is equals to mass into acceleration following Newton's second law. So mass into acceleration, which is 1. So 26 cos 45 minus 12 is equals to mg sine alpha, which is half, plus m. So taking a common factor of m, we can get m into g by 2, or g into half, plus 1 is equals to 26 cos 45 minus 12. So m is equals to 26 cos 45 minus 12 whole divided by half into g plus 1, and this is approximately equals to 1.08 kg. Now let's move on to friction. Friction is a force which opposes motion between two rough surfaces. It occurs when the two surfaces are moving relative to each other, or when there is a tendency for them to move relative to one another. This block is stationary. There is no horizontal force being applied, so there is no tendency for the block to move. Therefore, there is no frictional force acting on the block. This box is also stationary. There is a horizontal force being applied which is not sufficient enough to move the block. There is a tendency for the block to move, but it doesn't because the force of friction is equal and opposite to the force being applied. As the applied force increases, the force of friction increases to prevent the block from moving. If the magnitude of the applied force exceeds a certain maximum or limiting value, the block will move. When the block moves, the force of friction will remain constant at its maximum value. When a particle is on the point of moving, it is said to be in limiting equilibrium. The limiting value of the friction depends on two things: the normal reaction R between two surfaces in contact and the roughness of the two surfaces in contact. You can measure roughness using the coefficient of friction, which is represented by the letter mu. The rougher the two surfaces, the larger the value of mu. For smooth surfaces, there is no friction and mu is equals to 0. The maximum or limiting value of the friction between the two surfaces F max is given by F max is equals to mu R, where mu is the coefficient of friction and R is the normal reaction between the two surfaces. So therefore we have the formula F max is equals to mu R. Let's do some exercises from 5C. For number 6, a sledge of mass 10 kg is being pulled along a rough horizontal plane by a force P that acts at an angle of 45 degrees to the horizontal. The coefficient of friction between the sledge and the plane is 0.1. Given that the sledge accelerates at 0.3 meter per second square, find the value of P. So first, let's label the diagram again, assuming the box is a particle, and this is P, which acts at an angle of 45 degrees. So this must be the weight, which is 10g or mg, because the mass is 10. This should be the normal reaction force, and this should be the frictional force or F max. Because the sledge is accelerating, therefore we can say that the sledge accelerates in this way to the left with a value of 0.3 meter per second squared. So first let's resolve the forces vertically. If this is the sledge or the particle, this should be R. This should be the weight which acts vertically downwards, which is 10g. And if this is P at an angle of 45, we can use the triangle to say that this is P and this is 45. So therefore, this vertical component should be P sine 45 from our previous discussions, because this component is exactly opposite to the angle, and this component should be P cos 45. So our relevant component or the vertical component is P sine 45. So therefore, resolving vertically, we can say that R plus P sine 45 is equals to 10g. So we can rearrange making R the subject to get 10g minus P sine 45. Now we know that F max is equals to mu R, if you remember the previous discussion. Therefore mu is 0.1 as given here. The coefficient of friction between the sledge and the plane is 0.1. So multiply it with R, which is 10g minus P sine 45. Now we can say, resolving to the left, if this is the particle, as usual, this is P with an angle of 45, and this is friction, and this is the direction of acceleration, which is 0.3 meter per second squared. So therefore, using this triangle again, we can see that the vertical component of P is P cos 45. So this should be P cos 45. So resolve into the left or horizontally, P cos 45 minus F max or friction is equals to mass into acceleration using Newton's second law, which is 10 into acceleration, which is 0.3. And so we can say P cos 45, which is root 2 by 2, minus F max, which is 0.1 multiplied with 10g minus P sin 45, and similarly sin 45 is root 2 by 2 is equals to 10 multiplied with 0.3, which is 3, and we get P root 2 by 2 minus 0.1 into 10 is 1, so this is simply g, and minus multiplied with minus is plus, so we get 0.1 multiplied with root 2 by 2, so that can also be written as root 2 by 20 P is equals to 3. So we can take a common factor of P from these two terms to get P root 2 by 2 plus root 2 by 20 is equals to 3 plus G. So therefore P is equals to 3 plus G, which is 9.8, divided by root 2 by 2 plus root 2 divided by 20, which is approximately equals to 16.5 newtons. For number 8, a box A of mass 2 kg is held at rest on a rough horizontal plane that is inclined at 30 degrees to the horizontal. The coefficient of friction between the box and the plane is 1 by root of 3. Box A is connected to a second box of mass 3 kg by a taut, light, inextensible string that passes over a smooth pulley. So first we need to draw the scenario. So this should be the plane, and this is the horizontal. So this angle should be 30 degrees. So therefore box A should be here with mass 2 kg. So this is A, and this is connected to a pulley system which we discussed in our previous video, and is connected to B, which is of 3 kg. So the weight will be 3g, and this weight should be 2g. So we can say, drawing the simplified version, this should be the pulley, and this is A, so this is 2g. This should be a reaction force R, this should be tension, and there should be a tension as well. And connected to the pulley we have B, which has a weight of 3g, similarly having a tension here and a tension here. So as we know, B will accelerate downwards, and similarly A will accelerate upwards parallel to the plane. So as we know, this should be 2g cos theta, which is 30 here because the angle is 30, and similarly the horizontal component of weight will be 2g sin theta as we explained before, so 2g sin 30. And so we need to find out the acceleration of the system. So we can say for A, drawing the particle again, this is tension, this is 2g sin 30, this should be 2g cos 30, and this should be the reaction force. And because the box, and if you remember, the plane is rough, therefore there should be a frictional force, which is F, acting opposite to the direction of motion, and this will be the acceleration. So resolving perpendicular to the plane, we can say that normal reaction force is equals to 2g cos 30. So now we calculate the frictional force or the maximum frictional force or the limiting value of F, which is mu multiplied with R. As we know, mu is 1 by root 3 into R. So 1 by root 3 multiplied with 2g cos 30. And as we know, cos 30 is root 3 by 2. So we get 2g multiplied with root 3 by 2. The root 3's cancel each other out. Similarly, 2 and 2 cancel each other out. And so we should get G being the force of friction. So now let's consider the horizontal motion, which is F plus 2g sine theta. 2g sine theta, which is 30. And here, this is the tension. So just like in our previous video, we have to make two simultaneous equations regarding tension and acceleration. So resolving parallel to the plane and upwards, we can say, because acceleration is towards t, therefore t minus f minus 2g sine theta, which was the horizontal component of weight, is equals to mass into acceleration, which is 2a. So t minus g, which was the value of f here, minus 2g multiplied with half, as sine 30 is half. Therefore, t minus g minus 2g into half, which is g. So we get t minus 2g is equals to 2a. And this is equation 1. So now let's consider the motion of B, saying for B, which looks something like this. This is 3g, and this is tension, which is accelerating downwards with a. Therefore, 3g minus t, resolving downwards, is equals to mass under acceleration, which is 3a. This is equation 2. So applying equation 1 plus equation 2, and we know that equation 1 is t minus 2g, and equation 2 was 3g minus t is equals to 3a. Therefore, t minus 2g is equals to 2a, and then 3g minus t is equals to 3a. So adding both equations, we can say that t get cancelled. So 3g minus 2g is g, is equals to 2 plus 3, which is 5a. So therefore a is equals to 1/5 of g meter per second square. And if you substitute the value of g as 9.8, we get 1.96 meter per second squared approximately. And this is our answer. Now let's move on to some questions from question papers. Here we have May 2020, question number 6. A railway engine of mass 1500 kilograms is attached to a railway truck of mass 500 kilograms by a straight rigid coupling. The engine pushes the track up a straight track which is inclined to the horizontal at an angle alpha, where sine alpha is 7 by 25. The coupling is parallel to the track and parallel to the direction of motion as shown in figure 3. The engine produces a constant driving force of d newtons. The engine and truck experience constant resistances to motion from non-gravitational forces of magnitude 1200 Newton and 500 Newton respectively. The thrust in the coupling is 2000 newtons. The coupling is modeled as a light rod. So first we have to find out the acceleration of the engine and the truck. In order to find the acceleration, we need to consider the simplified diagram of the bodies. So this should be the engine with a weight which is 1500 g, and this should be the rod which has a thrust T in this direction and which also has a thrust in this direction in T, and this should be 500 kg, so therefore the weight is 500 G. We also have resistive forces for the engine, which is 1200 newtons, and for the truck it is 500 newtons, and there should be a constant force of D made by the engine. So because we don't know the value of D, therefore we have to consider this system or the system of the truck. So we can say for truck, if this is the truck, this is 500 G, we should have a resistive force of 500 newtons, and this is the thrust as displayed here. And so the horizontal component of weight is 500 G sine alpha. So therefore, resolving parallel to the plane upwards, because acceleration is upwards, therefore thrust minus 500 G sine alpha is equals to mass into acceleration, where mass is 500 multiplied with acceleration. So because thrust is 2000, therefore T is equals to 2000 minus 500 G multiplied with sine alpha, which is 7 by 25. So 7 by 25 is equals to 500 multiplied with acceleration. So making A the subject, we get 2000 minus 500 G multiplied with 7 by 25 divided by 500, which is equals to 0.256 meter per second squared, or can be written in two significant figures of 0.26. For number B, we have to find out the value of D. As we know, this is the engine. There should be a force of D here. Thrust should be in this direction, as well as a resistive force of 1200, and this should be 1500 G, because its weight is 1500 G, which is mg, and acceleration is this way that we found being 0.256, and so therefore we can resolve upwards parallel to the plane again to get D minus thrust minus 1200, and then minus the horizontal component of the weight, which is 1500 G sine alpha again, because as we know, this part is cos alpha and this part is sine alpha, or here, is equals to mass into acceleration. So 1500 into acceleration, which is 0.256 meter per second square. So rearranging and substituting the values, D is equals to thrust, which is 2000 plus 1200 plus 1500 G multiplied with sine alpha being 7 by 25 plus 1500 into acceleration, which is 0.256, and so calculating we get 7700 newtons, and this is our driving force D. So now let's move on to another question, which is from Jan 2020, question number 7. It's given that a particle A of mass 4 kg is held at rest on a rough horizontal table. Particle A is attached to an end of a string that passes over a pulley P. The pulley is fixed at the edge of the table. The other end of the string is attached to a particle B of mass 3 kg which hangs freely below P. The part of the string from A to P is perpendicular to the edge of the table, and A, P and B all lie in the same vertical plane. The string is modeled being light and inextensible, and the pulley is modeled as being small, smooth and light. The system is released from rest with the string taut. At the instant of release, A is 2 meters from the edge of the table and B is 1.4 meters above a horizontal floor, as shown in figure 3. After descending with constant acceleration for 2 seconds, B hits the floor and does not rebound. Show that the acceleration of A before B hits the floor is 0.7 meter per second square. For number A, we are given that time taken is 2 seconds, displacement is 1.4 meters by B, because B is the particle that falls through a distance of 1.4 meters and has the same acceleration as A. And then we also have an initial velocity of 0 because both particles were at rest. So we can use the equation S is equals to ut plus half into at square to find out A, because we don't know the value of A. So S is 1.4, U is 0 multiplied with T, which is 2, plus half into A into 2 square. So 1.4 is equals to 0 plus half into 2 square into A, which is 4. So therefore A is equals to 1.4 divided by 2, which is 0.7 meter per second square. And this is our answer. For number B, state which of the modeling assumptions you have used in order to answer part A. Now, they already have given us many assumptions, one being the string, which is light and inextensible. The pulley is modeled as being small, smooth and light. So for number A, we are assuming that both the acceleration of A and B are same. Therefore, we have used the assumption that the string is inextensible, as we discussed in our previous video about modeling assumptions. So therefore, we can say that the string was considered to be inextensible. So therefore, the acceleration would be same for both A and B that we discussed in our previous video. For number C, we have to find out the magnitude of the resultant force exerted on the pulley by the string. So let's draw the diagram. If this is the pulley, and as you know, if this is B and if this is A as a particle, therefore there should be a tension here. Similarly, a tension here. So this is tension T, this is also tension T, and if there is a tension here, there is also an opposite tension here. So this is B with a mass of 3, so therefore the weight is 3g. So considering the pulley only, this is T and this is also T or tension, and these are at right angles to each other. So if we draw a right angle triangle for the addition of the vectors, this is T, and so this should be the resultant force. So to find out the value of R, we need to find out the value of T first. So we have to use this system for B. So saying for B, this is 3g or weight, and this is the tension. Acceleration is downwards. So therefore 3g minus T resolving downwards is equals to 3 multiplied with acceleration, which is 0.7. So therefore tension is equals to 3g minus 3 multiplied with 0.7, and so the tension is 27.3 newtons. And therefore using Pythagoras we can say that r squared is equals to t squared plus t squared. Just to illustrate, if this is tension and similarly this is also tension, therefore if this is t and this is also t and the angle between them is 90, therefore the resultant should be the hypotenuse of the right angle triangle. So therefore r is equals to root over t square plus t square, which is 2 multiplied with t square, so 2 multiplied with 27.3 whole square, which is also 38.6 newtons. Now they said that the coefficient of friction between A and the table is mu. Find the value of mu. So if we draw the diagram again, this should be the flat horizontal plane. If this is A, we know that the mass of A is 4 kg, so therefore the weight should be 4g. This should be the reaction force, this should be a tension, and because acceleration is this way, the frictional force which acts opposite to the direction of motion should be towards the left. Now resolving vertically upwards or downwards, we can say that normal reaction force is equals to the weight, which is 4g. Therefore F max or the limiting value of friction is equals to mu r. Mu is unknown, therefore we write that being 4 mu g. Because acceleration is towards the right, so therefore t minus F max is equals to mass into acceleration, which is 4a. So t was 27.3 newtons. F max was 4 mu g is equals to 4 into acceleration, which was 0.7. So we can rearrange for the symbol of mu. 27.3 minus 4 into 0.7 is equals to 4 mu g. Therefore mu is equals to 27.3 minus 4 into 0.7 divided by 4g, and the value of mu is 5 by 8 or 0.625, and this is the value of mu. For number A, we have to determine by calculation whether or not A reaches the pulley. So if you remember the diagram, the whole length of AP, the string, is 2 meters. So we have to calculate whether the particle A will reach the pulley or not. First, we have to consider the motion of A. So if you remember, if this is A and if this is the pulley and this is B, B was initially 1.4 meters above the ground and A was 2 meters from the pulley. So from our previous video, we have established that if B moves a distance of 1.4 meters, i.e. falling to the ground, therefore A also must move a distance of 1.4 meters because they are connected. So we can calculate the final velocity of A just as soon as B hits the ground. So we know that S is equals to 1.4, acceleration is 0.7. So S is equals to 1.4 for B. Initial velocity was 0. Acceleration was 0.7. Time also was 2 seconds. We need to find out the final velocity. We can use v is equals to u plus at, and we can also use s is equals to u plus v divided by 2 multiplied with t. So using any of the equation, for this one we have v is equals to u, which is 0, plus a into t, 0.7 into t, which is 2. So we get 1.4 meter per second, meaning the velocity of a as soon as b falls to the ground is 1.4 meter per second. So now we have to consider the motion after traveling 1.4 meters. So initial velocity of a is 1.4 meter per second, and it only needs to travel a distance of 0.6. Now we know that there is friction acting, therefore friction, or F max, acts as the resultant force towards the left. So there will be a deceleration towards the left, and so resolving towards the left, we have F max is equals to mass into acceleration, which is 4 into acceleration, and because the force is resistive, therefore this should be negative. Mu was 0.625 multiplied with r, because we know F max is equals to mu r. So using that formula, we have r is 4g equals to 4a. So therefore a is equals to minus 0.625 multiplied with g, which is also minus 49 by 8 meter per second square. Now we have to consider the motion of a. So as we know, as a travels towards the pulley, there will be an acceleration or deceleration to the left. Therefore at one point a must have a velocity of 0. Let's name it as the final velocity v, where the velocity is 0, and we can find the distance traveled by the particle a within that point. So we know acceleration is minus 49 by 8, final velocity is 0, initial velocity was 1.4 meter per second, and we need to find the displacement. We can use the equation v square is equals to u square plus 2as. Therefore s is equals to v square minus u square by 2a. Final velocity was 0, so 0 square minus initial velocity, which is 1.4 whole square, divided by 2 multiplied with acceleration, which is 49 by 8, and so the answer is 0.16 meters. Therefore total distance traveled by the particle a is 1.4 meters, as b also traveled a distance of 1.4 meters, plus this distance, which is 0.16, which totals to 1.56 meters. Because initially particle a was 2 meters from the pulley as stated in the question, therefore during the motion it only traveled to 1.56 meter, so it stopped right here, and so we can say a did not reach the pulley. Thanks everyone for watching this video. Make sure to leave a like, comment, share and subscribe if you enjoyed the video. See you guys in our next video. Goodbye.